Good afternoon to the chair, Dr. Bauer, specially invited guests, my fellow panelists, and all participants this afternoon. As Dr. Bauer introduced, this study is What Color is Your Urine? The Effect of Exercise on Hydration Status in Student Athletes. According to Armstrong, hydration status is a broad term used to describe the hydration state of the body, the explanation of which includes three definitions. We can look at dehydration, which can be either acute or chronic, euhydration, which is water balance, or hyperhydration, which is positive water balance. When dehydration is acute, it is induced by exercise. When it is chronic, it is induced by the lack of proper fluid supplementation. Euhydration is a state of being in water balance, as I previously said, and Armstrong points out that this is not a static point, but it actually is represented by a sinusoidal wave, and it oscillates around an average. Hyperhydration can be defined as both positive water balance and a temporary increase in total body water above the usual basal level. Despite the dangers of dehydration, many athletes do not hydrate themselves before, during, and after physical exercise. The physiological changes that vary in degree from dehydration affect the central nervous system, the cardiovascular system, the thermoregulatory system, and also their metabolic pathways. As a consequence of these aforementioned changes, physical performance in athletes is diminished. They also experience problems such as dizziness, cramps, heat strokes, heat cramps, exhaustion, dry mouth, and that's just to name a few highlighted by a study that Bradford did. Another alteration in the body that is caused by hydration is weight gain and weight loss. In a study done by Kleiner in Water as an Essential Nutrient, it was reported that body fluid loss that amounts to about 2% of body weight carries the consequence of impaired physiological changes and performance responses. Because of these negative effects, they advise that athletes hydrate themselves before, during, and after exercise. To our knowledge, no previous study has been recorded on hydration status in athletes in Trinidad and Tobago. Therefore, the purpose of our investigation was to look at the effect of exercise on hydration status of student athletes from the UWI St. Augustine campus. We went about this with a systematic sampling method, which is a type of probability sampling method in which the sample population is selected from the broader population, and this can be simply put as 1 in every 6 student athletes participated in this study. The sporting activities that we got participants, voluntary participants from, were football, basketball, swimming, netball, volleyball, cricket, field event, which was shot put, and track. The instrument that we used to collect this data was a urine color scale, which was calibrated, and we looked at different colors, took the urine samples, and compared them against the scale. We also used a bioelectrical impedance analysis scale to look at the weight of the athletes before and after their physical exercise. The data was analyzed using SPSS and a paired sample t-test, which was used to compare the variation between the before hydration status and the after exercise hydration status. And this test was also used to compare the before weight to the after weight of the athlete. The significance level was set at 0.05. Our demographic data shows here that 69% of our participants were male and 31% were female, and we had a greater male population, and this could have been attributed to the fact that our exclusion criteria were menstruating females, because this may have altered the color of the urine sample. From here, you see in figure 2 that 23% of our participants were in the sport football, We had both the male football team and the female football team. We had 15% from swimming, volleyball, and also basketball, 16% from the track team, 6% from both cricket and netball, and also 4% in the field events. Our results, as highlighted in figure 3, shows the hydration status before physical activity. And the blue area represents a state of hyperhydrated, so they were in positive water balance. The red shows normal water balance, euhydration, and the green area shows dehydration. And if you compare figure 3 to figure 4, you see that after exercise, there was a significant change in the hydration status towards dehydration. And it is noteworthy to look at the field of swimming in figure 4, where most of the participants actually became hyperhydrated after their physical activity. Table 1 shows the difference in means between the before and after hydration status. And based on the paired t-test, we see that the p-value was less than 0.001, which suggests that there's a low probability that this occurred merely by chance. And thus, exercise does have an effect on the hydration status of athletes. And our study shows that they become more dehydrated after physical activity. Now we go on to looking at the weight gain. In terms of weight loss, we found that, in terms of weight loss, we found that 17% of the participants had weight loss exceeding 2%. And as I mentioned in the background, weight loss greater than 2% has negative physiological effects on athletes. And if you look at something as simple as fluid supplementation before, during, and after exercise, we see that this is a problem that could totally be eliminated by a simple solution. This simply gives you a graphical representation of the weight gain or weight loss of every participant after their physical activity. We see that below the graph, some participants actually gained weight after their physical activity, and this may have been attributed to some participants actually having fluid supplementation during their physical activity. We did not monitor in this study who drank water or who had fluid supplementation during the activity, but we suppose that this could have contributed to weight gain. Table 2 shows the result of the paired sample t-test for both the hydration status and the weight before and after practice. And we see that there's a significance in both fields. For this study, we concluded that urine color does change after exercise, indicating alterations in hydration status. And in this study, this showed that UE student athletes most of them do become more dehydrated, suggesting that there's not proper fluid supplementation before or during their physical activity. There's a significance in weight change as a result of exercise, and closer attention should be paid to fluid supplementation and also the individualization of fluid intake for each athlete for their respective sport to reduce possible negative hydration effects. I thank you for listening to this presentation.
Thank you very much. Also, very interesting presentation. And I also believe there will be many questions and the discussion will take place, as I said, later. And the next presentation is titled Nutritional Knowledge and Attitudes of Adolescent Swimmers in Trinidad and Tobago. Is going to be presented by Ms. Safia Beckford, also an undergraduate student of the section of Human Nutrition and Dietetics, Faculty of Food and Agriculture, UE, St. Augustine. So please, you're welcome.
Good afternoon, Dr. Bauer, fellow panelists, and all participants. As Dr. Bauer said, I would be presenting on the nutrition knowledge and attitudes of adolescent swimmers in Trinidad and Tobago. Background into our study: nutrition is an essential component of any physical activity program. Researchers have shown that high levels of nutrition knowledge and a positive attitude towards nutrition can result in increased performance and health of an athlete. Existing studies are constant in their findings that athletes lack nutrition knowledge they need in order to benefit from increased performance and health. This may be due to misconceptions about nutrition and its importance to health and performance among athletes. It may also be due to misconceptions or incorrect information given to these athletes by one or more unreliable source. Attitude towards nutrition is also important to the performance of athletes. Several authors have shown that athletes have a positive attitude towards nutrition, so this would mean that most of them might be open towards gaining nutrition information. In this context, we assess the level of nutrition knowledge and attitudes of adolescent male and female swimmers in Trinidad and Tobago. The main objectives of our study were to assess the level of nutrition knowledge possessed by adolescent swimmers, to evaluate the attitude towards nutrition held by these swimmers, and to determine if there was a relationship between nutrition knowledge and attitudes towards nutrition. This was a cross-sectional descriptive study which used a self-administered structured questionnaire to evaluate the nutrition knowledge and attitudes. The survey instrument utilized in this study was developed from a combination of two previously administered questionnaires. A total of 220 adolescent male and female swimmers aged 11 to 21 volunteered for this study. All the participants were registered and trained competitively with private swim clubs in Trinidad and Tobago, and at the time of the study, all of the swim clubs were registered with the Amateur Swimming Association of Trinidad and Tobago. The questionnaire included a demographic section, which gave a profile of the athletes, 21 nutrition knowledge statements, which they could answer true, false, or not sure, and 11 statements to evaluate attitude towards nutrition, which participants responded using a Likert scale, and the options ranged from strongly agree to strongly disagree. To assess nutrition knowledge, correct answers were given a score of 1, and incorrect answers were given a score of 0. And those that responded not sure were given a score of 0. For the evaluation of attitudes towards nutrition, a score of 1 to 5 was assigned to each question. 5 was given to the most positive response, and 1 was given to the most negative. All the data that we collected were analyzed using SPSS version 21. Analysis of variance were used to compare the nutrition knowledge and attitudes between sex, age range, highest level of education, and number of nutrition classes attended. And Pearson's correlation was used to compare the relationship between nutrition knowledge and sources of information, and between nutrition knowledge and attitudes towards nutrition. Our results revealed that the study population consisted of 98 females and 122 male swimmers. Most of the participants were in the 15 to 17 age range. They attended secondary school, and the majority of the swimmers were of mixed descent. Over half of the participants had never attended a nutrition class before starting to swim, and over half of them had never attended a nutrition class since beginning to swim. Most of the respondents indicated that they got their nutrition information from coaches and parents, whereas only 1.6% 7.7% of the swimmers stated that they received nutrition information from dietitians or nutritionists. The results also revealed that there was no significant difference between the means for knowledge score when compared between sex and age range. And what that means is that males did not necessarily score higher than females or vice versa, and there was no great difference between the scores between the age groups. However, there was a significant difference in the knowledge when the means in relation to number of nutrition classes attended since starting to swim were compared. So the more nutrition classes they attended, the higher the score. We also found that participants were deficient in the following areas, as demonstrated by less than 50% of the participants responding correctly. These areas were the role of protein in the body, the role of micronutrients in the body, especially iron, types of fats, the characteristics of carbohydrates,